So the last thing we have to look at is forcing with damping. Okay, so we have the same differential equations that we've been working with, y double prime plus 2y prime plus 9y, and y double prime plus 10y prime plus 9y. And we're going to set them equal to cosine 5t. So we have the non-homogeneous term. This is always, just a reminder, going to be a trig function. Okay, so to solve this system, to solve these differential equations, you'll need the general solution, which we already have worked out. So that's c1 e to the negative t cosine root 8t and sine root 8t, plus the particular solution. So for y particular, you see that cosine 5t is not part of the complementary solution. So we can use y particular to be equal to the cosine of 5t. So that means y prime is minus 5 sine 5t, and y double prime is minus 25 cosine 5t. Now, plugging that back into our differential equation, y double prime plus 2y prime plus 9y equals cosine 5t. We see that minus 25 cosine 5t plus 2 times, oh, I'm sorry, I made a mistake. I'll put my mistake in red. We want this to be a cosine 5t plus b sine 5t. All right. So now with that in mind, we get this to be plus 5b cosine 5t, and this minus 25b sine 5t. So let's cross that out. Got a little bit ahead of myself. Okay, so now plugging this in, y double prime is minus 25 cosine minus 25a. I need to put in my a's. That's an a and that's an a. So minus 25a cosine 5t minus 25b sine 5t plus 2 times y. What's y? Y is minus 5a sine 5t plus 5b cosine 5t. And then we're going to add 9 times y. So 9 times y is 9a cosine 5t plus 9b sine 5t. And that's going to be equal to the cosine of 5t. All right. So let's distribute the two and see if we can combine like terms here. Here we have a cosine 5t. Here we're going to have a cosine 5t. And here we have a cosine 5t. So we have minus 25a plus 9a. So that's minus 16a on cosine 5t. But we have a plus 10b cosine 5t. All right, because the 2 and the 5 give me my 10. Looking at the sine 5t terms, we have a negative 25b and a positive 9b, so that's minus 16b. I'll go plus negative 16b. So that term's taken care of, that term's taken care of. Minus 10a sine 5t. And that's all equal to the cosine of 5t. Oops. There. All right. Now, piecing this all together, we come up with negative 16a. Where's the 10a? The 10a is inside the parentheses. Sorry, this is a mess. We get minus 16a plus 10b cosine 5t equals 1 cosine 5t, and minus 16b minus 10a sine 5t is equal to 0. All right, so now we need to find the A and the B that make that work. Simply multiply this by, let's say, 16. Okay, multiply this by 10. What do we get? We got 16 times 16. Don't have a calculator with me, so 16 by 16. 196? No. 6, that's 9. 6, 0, 1, 256. That seems right. Yeah. Negative 256A plus 160B equals 16. And this is minus 100A minus 160B equals 0. So if we add these equations together, we get 16. That drops out. And that's a negative 356A. So that implies that A is equal to 16 over negative 16 over 356. Okay, so if that's true, then how are we going to find B? Okay, we can reuse any one of these equations. Okay, if I use equation 2 that says negative 10A minus 16B equals 0, that means negative 10 times negative 16 over 356 equals 16B, adding this term to the other side. So these two cancel out. I have 160 over 356 equals 16B. So that implies that B, oops, am I in the screen? So that implies that B is equal to 10 over 356. All right. Piecing this together. A is, so this is minus 16 over 356. What's A representing? The coefficient on cosine 5t. Plus B, that's 10 over 356 sine 5t. All right. And there you go. That's the general solution. Now, before we do the second example, I want to take note of a couple of things in this last half page. Okay, if time-dependent solutions, okay, that's what we have. We have the position of the mass is a function of time. If they can be decomposed in the form yt plus ys, where the limit as t goes to infinity of yt is 0, and the limit as t goes to infinity of ys is not 0, then we call yt the transient part and ys the steady state part. Okay, so that means the transient part is the component of the height that will go away over time, where ys is the component of the general solution that will always remain. Now, if you look at the two pieces that we have here, we have some constant. Let's see, make sure it's in the screen. Yeah, we have some constant times e to the negative t times cosine of root 8 times t. Well, that e to the negative t is really e to the t in the denominator. Same thing right here. As time goes to infinity, these two terms, the ones that are in green, are going to go to 0. Okay? Because the exponential will always be larger than the cosine of root 8t, where the terms in red do not go to 0 over time. Okay, they persist. So if we wanted to capture the transient and steady state, this would be yt, and this would be ys. Okay, this is the part that goes to 0 as time goes to infinity. This is the part that remains. It's not a surprise. The steady state, okay, portion of the general solution is the part that's attributable to the fact that there's forcing. Okay, this is the part that's attributable to the fact that there's a drag or a damping effect. Okay, and the damping effect will eventually go away over time. But this is the part that is persistent because there's a force that's being applied. That's according to what? The right-hand side cosine 5t. Okay. Oops, sorry about that. Something popped up on the screen and I thought the video turned off. All right, moving forward. Y double prime plus 10y prime plus 9y equals the cosine 5t. It's a very similar type problem, okay, where the general solution will be y complement plus y particular. Okay, hopefully this one will go a little bit smoother than the last one. From previous work, this is y complement. Okay, so what is y particular? It's a cosine 5t plus b sine 5t. Let's take a couple derivatives. So y prime is minus 5a sine 5t and 5b cosine 5t. And y double prime is what? Minus 25a cosine 5t and minus 25b sine 5t. Okay. Plugging this into our differential equation, we get, this is the differential equation of y double prime plus 10y prime plus 9y is equal to the cosine of 5t. So let's make sure we do that. See if I can set this up in a little different way that's maybe a little more visually appealing. So we have y double prime is of p minus 25a cosine 5t minus 25b sine 5t. 10 times y prime is going to be 10 times negative 5a. So that's negative 50a sine 5t. So negative 50a sine 5t. I'm going to line this up with the sines. And 50b cosine 5t. And lastly, 9y and these are all added together, so add and add, is 9a cosine 5t, 9a cosine 5t, plus 9b sine 5t. So when you add up the left-hand side, you're supposed to get cosine 5t. And when you add up the right-hand side, you get negative 25a plus 9, so that's negative 16a plus 50b times cosine 5t minus 16b, so put this plus negative 16b minus 50a times the sine of 5t. All right, that looks a little bit cleaner and easier to follow. So we can see here that negative 16a plus 50b is to equal 1, and negative 50a minus 16b is to equal 0. And then solve the system. Multiply this by 16, multiply this by 50. So we already know this is negative 256a. 16 times 50 is the same as 100 times 8. So that's plus 800b. And that's going to be equal to 16. And 50 times 50 is 2500a. That's a negative. Minus 800b 0. So we add these together. We get this minus 2756. A is equal to 16. So A is equal to 16 over negative 16 over 2756. I'm going to add that part of this. So it's minus 2756 minus 16 over 2756 cosine 5t. And let's find out what b is. So we have negative 50 times a. That's negative 16 over 2756. Minus 16b is equal to 0. So that's 50 times 16. I'm not going to do that yet. Over 2756 is equal to 16b. 16's cancel, so b is 50 over 2756. So that's plus 50 over 2756 sine 5t. Now, is there a piece of this solution that's transient? That means, will it go away over time? Yeah, all the negative exponentials. This is y transient. And these right here will not go away over time. This is our steady state. So if you're looking for a graph of what this is suggesting, what you're kind of seeing is that there's an initial wobble, up high, down low, and so on. But over time, the waves are consistent. And they're given to you by this function in here in red. So the transient part is really the up and down, and the steady state is the part that remains over time. Okay, that's probably, the second graph is probably a little bit better visual as to what's going on. All right. And one last thing to note, the transient part is the complementary solution. The steady state part is from the particular solution. Okay, so that's the end of section 8.5. It's really just a continuation of section 8.3, or at least an application of section 8.3. Hope you're all doing well, and all the best.